Hi, my name is Carlo Papera, Product Manager of the Handling and Washing Equipment at IMA Active. Today, I'm glad to introduce our technologists from the IMA laboratory, Caterina Funaro and Giusy Mondelli, involved in CIP optimization either in an industrial perforated coater or granulation equipment in cooperation with Thomas Altman from Ecolab, supplier of cleaning agents. IMA Active designs and manufactures machines mainly for the pharmaceutical, nutraceutical, and food industries, with a strong focus on cleanability at product changeover to ensure perfect and repeatable cleanability and allow validation of the cleaning process. Atlantis washers for cleaning either IBCs and machine parts, Venus washer specifically designed to clean machine parts, the new Aquaria part washer, and hydro washer skids for CIP of the IMA machines are the wash equipment designed and manufactured by IMA Active with the aim of reducing water and detergent consumption and at the same time ensuring optimum washing performance. When designing an IMA machine, cleanability is one of the predominant themes with an impact of mechanical construction, choice of materials, and finish to avoid cross-contamination and release of polluting particles. All surfaces in contact with the product must be easily cleaned and sanitized in accordance with current regulations. Not least, the control system of the IMA machine will enable to perform a wash cycle according to a validated recipe. The washing unit used for cleaning the Perfima coater and rotogranulator line shown in the webinar today is our HydroWash F-skid model, complete with a centrifugal pump, detergent dosing group, water heat exchanger in line, and other accessories to monitor the washing process, including water temperature, pressure sensor, water flow rate sensor, and detergent flow rate sensor. Washing itself is a process. And behind it, a team of IMA engineers is dedicated to the study of cleaning problems, suggest proper detergents and chemicals to perform a better cleaning, improve machine design to increase washing efficiency. Our goal is to enable our customer to wash correctly and in less time to ensure product quality at a lower cost. At this point, I have the pleasure of introducing Thomas Altman from Ecolab, Life Science Divisions.
Hello, my name is Thomas Altman. I'm one of the global technical consultants of the Ecolab Life Science Division. One important factor of the cleaning is the detergent, and I would like to discuss this in a short presentation with you. The regulatory requirements for detergents and also some basics on cleaning in the pharmaceutical industry will be reviewed. For that, I would like to go into a discussion of a standard cleaning procedure. So on the chart here you can see a standard setup of a cleaning procedure. All cleaning procedures in common have that they are following the same principle. So you can see the 4 round circles on the right hand side. This is the so-called Zinner circle. So you need for each of the cleanings to be effective a certain cleaning time, a certain cleaning temperature, as well as a cleaning chemical and mechanical action. So these kind of parameters can vary, and the variation of the parameters can be done in some systems very easily, so that you can, for example, play around with the temperature for cleaning due to the fact that you have a heater in place, or you have to have a kind of pump setting what you can influence, but sometimes it is fixed. For example, in the parts washer, you have always following the same program with the same pressure in the washer. Then you are minimized, and maybe here some cleaning factor is missing. So if 2 factors are missing, for example, the temperature and the mechanical force is fixed due to the fact that you are using, for example, a parts washer, then this kind of cleaning can only be manipulated if you use another cleaning chemistry or if you clean for a longer cleaning time. When we talk about cleaning, we also have to look to the different applications. So a manual cleaning requires for sure a different cleaning approach and temperature compared to a cleaning in place situation. Manual cleaning is an involvement of the operators directly. Cleaning in place, the operators press a button and the cleaning starts. So this kind of considerations is also to be considered if you want to talk about an effective cleaning. And if somebody is asking me, what is a proper cleaning agent? I would always ask them, what do you need it for? Is it for a non-sterile application or for a clean room sterile application? Is this something where you want to clean a product contact surface, or is it something where you do want to clean up a non-product contact surface? And what is the application of cleaning? Is it a manual? Is it a washing in place? Is it a cleaning in place? Or even a foam cleaning or soaking? Some special requirements may be also existing due to the fact that you might need a certain pack size to fit it into a washer, or that you need a certain pack size to have it attached to another system. So what is a detergent? Detergent is a complex mixture of several cleaning components formulated to achieve a desired cleaning on specified residues. And this can be like dispersing agents, complexing agents, oxidization boosters, defoamers, alkalinity, acid sources, and all these components will then drive also how to analyze the detergent afterwards for cleaning validation. If we talk about cleaning agents, we can also see that in a lot of regulations there is something outlined about how a cleaning detergent or how a cleaning agent should look like. So the formulation must be unchanged. You should avoid critical substances like toxicological, dangerous substances. Ecological and rinse profiles are really important because a cleaning agent has to be completely rinsable. This is what the FDA requires. Non-colorants and no perfumes in a detergent is a good idea for the pharmaceutical industry, as well as that analytical methods are available, and therefore you need to know the formulation of the product to analyze residues on detergents. You have to consider breakdown if the detergent is breaking down your active or if the detergent is consumed over the cleaning time. Even a change notification, if there is a critical change in the cleaning agent, should be set it up with you, and a lot of people are at the moment going into the direction of making a qualified supplier agreement, so a quality agreement in place with the detergent manufacturers. So now you know some details concerning detergents and the requirements for the pharmaceutical industry. We will come now to another important factor in the cleaning. This factor is water, respectively the water consumption. I will hand over to Katharina on this topic, water consumption and CIP optimization.
Welcome also from my side. My name is Caterina Funaro and I am Process Laboratory Responsible at IMA Active in Bologna. Always more often, a large number of pharma companies are looking into water amount optimization by using a reduction and recovery strategy. New innovations in equipment and CIP technology design can improve water consumption through the various steps of the cleaning cycle. Operational efficiency, process design, and advanced automation are key elements to improve CIP water optimization. The amount of water and chemicals used can be also reduced by introducing recovery systems so that the liquid can be reused instead of sent down to the drain. Beside a proper CIP design, an efficient cleaning recipe is based on some key parameters: temperature and concentration of cleaning fluids, speed, pressure and flow of liquids managed during the washing recipe. A final check can be made following the last rinse, and in many cases the software will be able to indicate a conductivity value useful to determine the end of the cleaning procedure. EMA, as a pharma equipment manufacturer, is truly focused on this topic, and we, as technologists, always perform tests to find the best solutions for an effective and efficient cleaning. We can report an interesting case study in which we conducted some tests to optimize the CIP water consumption of a Perfima 250 liters perforated coater, provided with a CIP system with spray balls and cleaning lances directed in all the areas that have to be cleaned after a process. Perfima CIP consists of several washing lines designed to cover all the coater internal surfaces and a recirculation system connected to the wastewater main discharge. The operator can select for each washing phase the possibility to perform either a go-through or a recirculation washing option. HydroWash washing skid properly supplies the Perfima CIP system, selecting the desired water type for each phase, controlling the water temperature with an inline water heat exchanger, and dosing the detergent with an automatic inline detergent dosing system. As a first step, the coater was contaminated using 150 kg of placebo tablets coated with Opa-Dry 85F pink prepared at 20% concentration in water for a theoretical weight increase of 3% of the course. This resulted in a 45-minute spray time process that was replicated 10 times in order to simulate an industrial production properly. First, to create a good comparison, a standard CIP as a reference recipe was performed after contamination procedure with the parameters shown in Table 1. COSA CIP72 acidic detergent from Ecolab was used since it can be considered a typical cleaning chemical for EMA equipment. The strategy to decrease the water consumption aimed to reuse part of the water, applying the recipe shown in Table 2. As you can see, in both phase 2 and 4, water was accumulated in the coater using the drum cabinet as a reservoir. This water, after its use, was then reused in phase 3 and 5 respectively, and good saving was obtained. Another implementation consisted in optimizing the rinsing phase with purified water, splitting the phase in 2 cycles and decreasing the total time of water delivery and amount. Literature reports that one cycle providing longer contact time and water delivery offers less improvement in rinsing effectiveness compared to more and shorter cycles with lower contact time and water delivery. In both sets of tests, the final result of CIP was very good in terms of visual inspection and water conductivity. Target of 4 microsiemens was achieved at the end of the rinsing step. Recipe optimization obtained by minor but effective changes in water time and the use of a recycling procedure led to an overall water saving of 590 liters, equivalent to a 30% water reduction compared to initial total water amount. Detergent quantity was also reduced by 30%. And now, Thomas, I'll hand it over to you.
You have just seen a strategy to reduce the water consumption using a practical example. I would like to outline now how you can identify critical cleaning process parameters and how to develop a cleaning process. This is important because you should know the process parameters needed for the cleaning to understand if there is even a possibility of optimization. we will go to look at a coater, to a coating cleaning as an example. And also I want to bring to your attention how cleaning process development studies are made these days. So if we talk about cleaning of coaters, you can understand that there is a low mechanical action often provided if you just circulate a cleaning solution in a coating drum. Modern systems have like high pressure lenses inside, but very often these kind of installations are missing in older systems. Also, coaters can be cleaned at lower temperatures because they are often even not connected to a CIP system. So this leads to very long cleaning times, and often also there is a need for manual intervention during the cleaning or after the cleaning or before cleaning for pre-cleaning preparation. So these kind of things already shows us that there are long cleaning times to be expected, and that even in some applications we still see today things like hard solvents used for cleaning of coaters, meaning acetone, ethanol or DMF or something like that. This is what we try to avoid. Generally we can outline, if you want to clean a coater, please have a look on the substances on the product you have just produced. Because if this is, for example, an acid-soluble coating you processed, then for sure the cleaning should be also acidic. Very often cleaning temperatures are concerned, and for these kind of coating materials in coaters, we can recommend very often ambient to maximum 50 degrees Celsius for cleaning. If you have a coating what is soluble at an neutral pH 7 to 9, something like that, then it is good to get for a neutral cleaning agent. And alkaline soluble materials are best solubilized with an alkaline detergent. The only thing where we would require high temperatures for cleaning is usually if you're dealing with sustained release or retard formulations. These are pH independent insoluble materials, and therefore we need specialty cleaning agents and often temperatures of 55 degrees and more. The Annex 15 tells us that we have to understand the cleaning process. So what kind of cleaning process is done? I have to outline where do I get the information that a certain temperature is the effective one, and even how the influence of this factor is coming into play when it's maybe not reached. So let me give you an example of how we are doing laboratory bench scale studies. So there are different ways of just making a solubilization test or doing some coupon studies. This is the most used cleaning agent testing. Beaker studies can be done to make a kind of simulation of for example, suspension vessel, and even small-scale mixers can also be used for laboratory trials. Lab-scale studies are there to identify what cleaning process parameter is driving the cleaning. So you gain cleaning process knowledge with these kind of trials. And an example of a design of experiments here shows that there is the impact of the temperature much more relevant to the cleaning than the detergent concentration. So even if you double the temperature from 40 to 80 degrees Celsius, you get more cleaning effect compared to if you use 5 times more detergent, from 1 to 5% of the detergent. This makes it clear. Here in this case, in this example, the cleaning temperature is very important for the cleaning. Also with lab scale studies, you can identify if a dirty hold time will impact the cleaning at all. And just to make sure you understand it correctly, laboratory bench scale studies are standing for lab results. And if you want to translate that into the real life, into your facility, there might be a difference between the full scale and the lab scale. What you have to identify is what kind of cleaning are you doing? Do you clean between different products, what is maybe considered as high risk? Or are you cleaning the dedicated equipment where you just might go to a visual clean and look at degradation products and impurities during the validation, and this is then considered as a low risk for cleaning. Let's now look and see how improvements in cleaning can look like in practice.
Welcome to everybody. My name is Giussi Mondelli and I am one of the process technologists of EMA Team Laboratory. Cleaning tasks required tailored procedures. In other words, each equipment washing cycle is unique and it is deeply optimized in order to achieve the most beneficial and cost-effective results. Very often, we are asked to provide our experience in supporting customers for washing improvements. To be successful, first of all, the design of equipment must be taken into consideration. Some types of equipment will be more difficult to clean than others due to the presence of valves or additional support dedicated to the special applications, installation of PAT sensors, and eye containment configuration. Another important factor to consider is how the equipment is used. Are you cleaning a product-dedicated manufacturing line, or your equipment is used to produce a wide range of products? And second, how many batches have been manufactured prior to washing? A general question is how to clean. To answer to this question, both process and equipment variables need to be investigated. Type of detergent and if it's suitable to remove the soils. Amount of detergent, because more is better, does not work in the majority of the cases. Water temperature that is strictly correlated with the detergent type and concentration. Cleaning method to apply, if it's a cleaning in place, or if some parts need to be disconnected and washed separately. Washing time that contributes to the effectiveness of your cleaning application. Surface to be cleaned and number of spray balls available that mostly depends on the size of equipment. Nowadays, the request of smart equipment is increased, and that's the reason why, from the HMI, it's possible to edit fully automatic recipes organized in a sequence of washing phases. The washing cycle for an automatic equipment as an iShear mixer granulator is carried out by introducing into the bowl the water from the impeller seals. A pre-washing always is recommended to remove most of the residuals. Spray bowls are strategically located to wash difficult-to-clean zones. Water filling plays an important role in improving washing efficiency and sustainability in terms of water consuming for both cleaning and rinsing phases. Once properly filled, washing time and impeller speed are the main critical parameters for enhancing mechanical action for an effective washing of the bowl and the upper part of the equipment. Finally, water is drained and the sequence can be repeated until the final rinsing. A real case study will be very well explained during the next speech, held by the expert of detergent. I give you the floor, Thomas.
In this last section, I want to give you an example of an optimization of a granulator cleaning we have done lately. Furthermore, I want to highlight a few projects and also to give you hints on cleaning of hard-to-clean formulations in oral solid dosage applications. Finally, considerations on sustainability for optimizing existing cleaning processes will be made. We know now that a cleaning process has some critical parameters we have to observe, like the cleaning time, the cleaning temperature, the mechanical action, and the chemical activity. So if we take this into account, we have to identify what is the most important factor for the cleaning. We heard that in my last presentation that we can do cleaning process development studies in the laboratory. And here is a case study of a filter cleaning for a granulator. We have seen that a filter cleaning for this granulator was carried out 24 hours only for one cleaning, because they have to clean multiple times just using water at 75 degrees C. We could reduce that down to 3 hours of an effective cleaning time with an even better cleaning result as before, because we used a detergent what was designed to remove this kind of coating processed in the granulator. Cleaning process development studies, not only like these for this filter, are leading to recommendations from the detergent supplier point of view. So we can, for example, outline that if you have pigments like iron oxide or titanium dioxide, you should not clean at a too high temperature. You should maybe limit the temperature to like 50 degrees, use a good detergent, and make only short cleaning cycles, not too long cleaning cycles, because then the material, so the pigment, tends to stick on the surfaces very hard as a film onto the surface. Other things like stearates require surfactants for cleaning, otherwise you will get a very hydrophobe surface of the equipment. Even cellulose can outline for us that if this excipient is present, we need an ambient temperature for cleaning and not a hot cleaning is required, otherwise we will not get an effective cleaning. For carbomers, for example, or gabopools, there is the requirement of please do not rinse that with water in the first instant, because that will result in a very sticky gel on the surface, what is nearly impossible to clean. So this kind of considerations have to be done, and we can then recommend, for example, for the carbomers, rinse it first of all with an acid detergent or with a complexing agent containing detergent. Then you prevent this gel formation. So your detergent supplier can already give you a good idea on what is an effective cleaning for specific applications or for specific raw materials. If we talk about cleaning in general, we want to normally look for optimizations. It is very seldom in pharma done in the past, but it's now more and more in focus because of sustainability issues. So here it's about to reduce cleaning times. This is what we have had a long time already, because you want to use your equipment for processing products and not for cleaning. But very often, if a cleaning is validated one time, you will never touch it again. We are looking for reasons to find the optimum procedure, and then even to give you some ideas on what should you do to make this optimized cleaning happening. And therefore we ask questions like, why do you do the cleaning as you do it today? Even if you have it in place since years. Think of that question. Is there a cleaning process development behind, or was it due to some of the experience? Maybe even some of your operators say, oh, this will work, and it worked out. But is this identified, if this is the right temperature, if this is the right concentration of the detergent? Ask your question, ask this question yourself. Also, the assessment of the change, if you plan to do a change, requires that you understand the cleaning process in depth. So only if you understand the cleaning in a good way, you can evaluate the risk of changing some procedures. I want to give you also a hint on the water you use for cleaning. Please look at the water for pharmaceutical use guideline, because that can tell you if a certain process can, for example, also be carried out using portable drinking water. And this is then a good source even to say, yeah, I've used purified water in the past, but I can save that, because if I want to make purified water, I have to use tap water as the starting material, and there is something, I need a certain amount of the water to generate it. So these kind of sustainability considerations are there. And so for us, it's always good to identify if you use the adequate, so the correct water quality for this purpose, if you have effective cleaning temperatures chosen for your processes, and also if you are using effective rinsing temperatures. Some surfactants rinse easier at cold temperatures, some of them at hot temperatures. And also that kind of information can be gained from your detergent supplier. At the end of the day, the final step is also to look if an automated process is possible for things you are doing manually currently, because an automated process is always easier to validate. I hope you enjoyed these different sessions today, and hopefully you got a few good ideas and possibilities for optimizations on your processes on your side. Also, you should now be able to facilitate a risk assessment in case of optimizing a few cleanings on your side. We want to thank you for your attention and hope you enjoyed the sessions, and we hope to see you again soon.
Thank you, Caterina, Giusy and Thomas, for this interesting picture of the cleaning tips to optimize the manufacturing of OSD products. Do not miss our next webinar dedicated to washing technologies, and get in touch with our experts through our website. And now our speakers are available to answer your question through the chat. Thank you for your attention and see you soon. Bye.